Hi everyone, welcome back to the channel. In this series, we are looking at Leetcode problems, and today we are looking at Leetcode 150 evaluates reverse Polish notation. In this video, we will be using a stack to help us solve this problem. It will help us store some values, and we'll also take a look at a functional interface in Java called int binary operator. Okay, so the problem states you are given an array of strings tokens that represents an arithmetic expression in a reverse Polish notation. Evaluate the expression, return an integer that represents the value of the expression. So if you don't know what reverse Polish notation is, typically you would see maybe 3 plus 4, but in this it will be 3, 4, and then your operator. So it tells us these notes that the valid operators are addition, subtraction, multiplication, and division. Each operand may be an integer or another expression. The division between two integers always truncates towards 0. There will not be any division by 0. The input represents a valid arithmetic expression in a reverse Polish notation. The answer and all the intermediate calculations can be represented in a 32-bit integer. So let's look at the first example. We're given 2, 1, addition, 3, multiplication. And so we'll need to add the 2 and the 1, and once we get that value, we'll want to multiply that by 3 equaling 9, and that's what we would return. So using a stack, what we're going to do is if we see an integer, we're going to push it onto the stack. As soon as we come to any of the operators, so one of these 4 operators, we'll then need to evaluate that expression. So I think one of the reasons why this is a medium is because, one, you have to store the integers, and then 2, you do have to evaluate it for its appropriate sign. So to break that into 2 parts, I mentioned we'll be using something called an int binary operator in Java. And what we want to do is ensure that as soon as we see a token that is an operator, that there's the correct mapping. So in this case, we are going to use a map. And we are going to map the operator that we see as a token to an int binary operator. And what that's going to do is we're going to pass it the integers that we want evaluated. It's going to evaluate our expression, and it will return our results as an integer as the value. Make that a map of, so on this part, we do have to go and make our map. So like I said, it's going to take 2 values, A and B, and in this instance, we want it to say A plus B. And then for subtraction, we pass in the subtraction symbol as our key. It's also going to take an A and B, and we want it to return A minus B. And we'll do that for their multiplication and division as well. They all take the 2 integers, and we have to tell it what we want it to do with that. Perfect. So now we have our map, and we'll call this map whenever we see a token. And so for our actual logic, we're not going to use a stack in Java. We're going to use a deck, but it will be used as a stack. We can just call it stack. And once we have our stack, now we want to iterate over our array of strings, which are tokens. And for each token, we want to check if we see a operator. And we can do that by asking, does our map that we create, our operations map, does it contain this key of token? And that will let us know if it's not one of these, then it's likely an integer, and we'll need to push that onto the stack. And so if it is one of these, then we want to pass it the two items, or two integers that we have on the stack, and have it return what we would want that. Now I'm going to start with our B because we're pushing it on the stack and it looks like this. Let's say 3 plus, or 3, 4 plus. This is going to be our B and this is going to be our A. In addition, it doesn't matter. But if we have a subtraction or division, our answer is going to be incorrect if they are not operated on or evaluated in the correct order. So the last item that we would have popped on probably would have been that 4, or it would have been that 4, and then the second to the last item that's on that stack would be the first integer, and we want to make sure we are putting those in the correct order when passing that into our binary operator. And we're going to push this onto the stack once it's operated on, because some of them can be nested and we'll need to use that integer again for possibly other expressions, or at the end we're just going to use it as a storage so we can pop it off, and you'll see what I mean. So we're pushing onto the stack. We're going to say operations.get token, and for that token we want to apply as int, and we'll pass in our A, we're going to pass in our B. That's going to evaluate, and that will push that result onto our stack. And this is the instance that it's not one of those tokens and it is a integer. We don't want to do any of this, we just want to push it onto the stack. And we need to put it onto the stack as an integer, so we'll call integer.parse int, pass in the token. And once we're done with our for loop, we'll go ahead and return the result, which should be on our stack because we pushed it onto the stack earlier. We'll go ahead and run that. And as you can see, our test cases have passed. And this is an O of n time complexity with an O of n space complexity for the stack that we had to create. And the map that we're using, it's very small, so that would be O of 1. And that is all for evaluating reverse Polish notation. If you all solved it in a different way, comment down below. I definitely want to know how else we can get this solved. See you in the next video.